Okay, let's go ahead and talk about one more thing in terms of calculus. And again, my volume's all the way up here. Okay, so for calculus, let's talk about some rules. Rules that we will use for derivatives, okay? We're going to have a very similar set of rules. You're going to see it's pretty much the exact same thing when we get to integrals, but I just want to introduce this now so you guys are familiar with it. What if you have some kind of a function, okay? You have a function that looks like x plus y. Now you got to take a derivative of these, right? Okay. Well, and actually, let's go ahead and do something so it's actually in the same term because you're going to do a function with respect to x because you're always going to do a derivative of one term, one dimension, right, with respect to that or something else, maybe with respect to time, something like that. So this is the variable you're actually going to change, right? So this is going to be the derivative of your function with respect to whatever variable you want, okay? So let's keep the variable the same here, and I'll just put different powers in there, okay? So my function, let's say it's x plus x squared. How in the heck do I find the derivative of that? I have two different things here. Okay, this is the first rule. Sum rule, difference rule, they're pretty much the same rule, okay? So how in the heck do we find this? Well, what you want to do is first, you want to take the derivative of the first part, okay? So you take the derivative of this, and you split these things up and make them different things, okay? So we can take the derivative of x, right? That's just x to the first. So imagine that your function was only x, okay, the first part, x to the first. Well, our derivative of that would be, again, drop the power down and multiply by it, 1 times, okay, our old thing here, the variable we're looking at, and then to the power minus 1, right? 1 minus 1. So 1 times x to the 0, or if we simplify that again, anything to the 0 power is 1, so it'll be 1 times 1, or just 1, okay? So if we're trying to find this guy here, the derivative of this, we've already found the first part of it, okay? The first part is just simply, instead of x, we get 1, okay? So that's an important thing to know. Anytime you have a single variable by itself to the first power, right, it just turns into 1 later on, okay? What about the second piece of this, though? Okay, well, okay, so let's look at that separately. Let's go ahead and find the derivative for that by itself. So instead of x to the 1, we got x to the 0, okay? So same process. Derivative of this, we drop down the power, so we get 2, okay, times our variable, and then the power that we had minus 1. So 2 minus 1, we get x to the first power, okay? So simplify it down, you get 2x, okay? So what was the derivative of this guy? 2x. That right there is our sum rule, okay? Sum rule says find the derivative for each piece and then plug them back together. Difference rule works the exact same way, okay? You plug it, you split it, find the derivative, plug it back in, okay? So that right there takes care of your difference or sum rule, okay? Find the derivative for each piece, and then plug them back together in the original equation, and you're good to go. Okay, what about the next one, though? Okay? For the next one, product. That means multiplication, right? Product is what you get for multiplication. So what if you had a function that was... I'm trying to think of a good thing here now. Okay, so what if we have x times... And I'm going to do times y here, okay? I'm trying to think of a better way of doing this, but we can find this, okay? So if I do this, what you'll find is that the product rule is very simple, okay? All you have to do is find the derivative for this one of them and leave the other one alone, okay? So if I want to find the derivative for this, if I'm looking at this with respect to, change of this with respect to x, okay, well in this case, x is going to change, okay, so I'm going to find the derivative of x, okay, first. So derivative of this is going to be, so if this were my function, let's just imagine that. Derivative of that would be, that's x to the 1, right? So what I would, let's make it more interesting. Let's make it x squared, okay? So if my original function is x squared, my derivative of that, bring the 2 down, multiply by my variable, and then the power minus 1. So 2 minus 1 gets me x to the first, or I just get 2x, right? So for my product rule, the first thing I get is I took the derivative of that one, and I'm going to leave this one alone. okay? So what I would get here is I would have 2x, derivative of that guy, times y we didn't even look at. It stays the same, okay? Now what we do for the second part of it, okay, is we imagine that we only have y here, okay? So it's y to the first, and again, I'm not actually looking at it in terms of anything else, okay? It's in terms of x, so the y doesn't change. So the derivative of that is still going to be y to the first. Because I didn't look, I'm looking at it with respect to x, right? But because y is there, what I will get here still, because it's multiplied, okay, x came on through because I did not look at that. I looked at the derivative of y, but the derivative of y with respect to x is going to be just y, okay? So I had derivative of the first, leaving the second alone, derivative of the second, leaving the first alone, okay? So that right there is going to be my product rule. Product rule, take the derivative of each piece, okay? The first one, when you find the derivative of that one, leave the other part there, stays multiplied. Then you add in, leave the first part alone, and the derivative of the second piece. Why did y not change? Because we're looking at it in terms of x. We can get into that more later, okay? If I was looking at it in terms of y, though, y would have changed to be, instead of that, it would have been 1 in the end. It's a constant, so it would have changed to 1, okay? Sorry, it's not a constant, it's a variable, but it was the first power, so it would have gone to 1, okay? All right, so that's the product rule. Chain rule. Let's look at the chain rule, okay? So the chain rule means I have to do things in, one after the other, and sort of like a chain, right? Links in a chain. So what if we have our function is x squared to some power? Let's say it's to the n power, right? We're going to change the number as we go, okay? And in fact, we could figure this out if we just put a number in there, but let's just go ahead and do it this way, okay? So my function is x squared to some value, okay? So how in the heck do I do this? Well, I want to find my derivative of this, as I always do. So what I do here is I'm going to have something multiplied by something else, okay? I'm going to do the derivative of one thing, leave the other one alone. I'm going to do it multiplied by the derivative of the other thing, having left the first thing alone, okay? What do I mean by this? Okay, so let's imagine that this is just some value, okay? If it was x to the n power, what would we do? So if our function was actually, if it was x to the n, right? If this was x in here, what would I do for my derivative? I would get my power get brought down, multiplied by my variable, and then it would be the old power minus 1, right? So that's what I'm going to do first. So my first thing here, okay, is going to be n to this function, and it was to the n before, so it's still the same function, that didn't change, okay? But my power here dropped by 1. It's to the n minus 1, okay? So now I'm going to do this for the second part. I leave this alone, and I take the derivative of this piece, okay? So now I'm just going to look at x squared. So I'm going to take the derivative of the outside times the derivative of the inside. Does that kind of make sense? So for this, I had x squared, right? So the derivative of that, bring my 2 down, times my variable, minus my power by 1. So 2 minus 1, I get 1. So I get 2x for the derivative of x squared. So in here, I'll get 2x as my derivative, and the outside stays the same, what it was originally, okay? So chain rule, do the outside part first, okay? Take the derivative like the inside was just a variable, okay? Plug it in. Leave the thing that was inside originally alone, okay? Then multiply it by the inside derivative with the outside left alone, and you've got your chain. And that's it, okay?